The current methods of water softening include ion exchange and lime softening. Ion exchange exchanges magnesium and calcium for potassium and sodium. It discharges mass quantities of salt brine into the subsurface and causes the overflow of septic tanks, and worst of all, it prevents the germination of plants. Lime softening uses lime to soften water, requires long detention time, and is used to adjust ppm, and it also releases harmful gases. Of these disadvantages, septic tank overflow causes bacterial infection and a pungent smell. Instead of using a chemical process such as ion exchange, I'm using electro-precipitation, which is a process that uses electrical attraction between the ions in the water and the two electrodes to reduce the amount of minerals in the water, such as magnesium and calcium. After a certain period of time, due to the electrical attraction between the ions in the water and the electrodes, the overall TDS will decrease, thus making the water safer for use. Here, it shows the specific ions attracted to each electrode. For example, at the cathode, magnesium, sodium, and calcium were attracted. As you can see, magnesium was positive, sodium was positive, and calcium was positive. Therefore, it will be attracted to the negative electrode. And the sodium bicarbonate and the chlorine and the sulfate will be attracted to the anode because they're negative, and the anode's positive. Through this attraction, the overall TDS will be reduced. In the data collection, a TDS meter was used to calculate the TDS before each process and after each process. Therefore, after conducting 10 trials in this experiment, I calculated the average effectiveness of each process. As shown in this graph, water softeners are 29.4% effective, and electroprecipitation is 25.7% effective. This apparatus could be used in the future by single-house families.